there we are. Good morning. How are you all today? Sorry, I'm
beautiful day of paradise. I am coping.
You're coping.
Doing good.
I'm running a little behind. See? The reason for that is I was setting up something on my desk here. I'm going to show it to you in just a moment. Once I'm finished setting it up, I have to apologize about what happened on Monday. See, I forgot to hit record as usual on the Zoom. So the only thing that was recording was my YouTube, which is fortunate, right? Because now I had a recording at least of the session. But then I showed another YouTube video to show you, and of course YouTube says you can't do that, right? You can't show someone else's YouTube video in your YouTube video. So during the live stream, they just blocked it out. And then later on, I got an email that said, sorry, because you included someone else's YouTube video in your YouTube video, we've blocked your entire video. So I had to go through last night and try to trim out the portion that YouTube, where the other video was. But I'm not even sure at this point whether they've made that video alive again so you can watch it. If there's any consolation though, we talked about quantum computing, which is not something central to this course. Neither is pretty much anything we're doing this week, because we're getting ready for next week, your finals week. How many of you have like lots of finals to do?
I just have two, and only one of them really matters. But yeah.
Well, that's good.
I mean, they're both like, actual STEM classes, so it's not like a gentle final.
Well, good luck on all that stuff. So as I said on Monday, and I'm falling behind again because stuff happening around the house. I still have to post that schedule where you can sign up for a Zoom class sometime next week. And I've got some, like Monday through Thursday, I've got morning sessions available, generally during the times when we would normally be here. Actually, I've scheduled on Monday and Tuesday for them to start at 10:30, so that we at least will be able to meet for about an hour or so on Monday. My Tuesday class also can meet for about an hour or so. And then the Zoom schedules start, so I've got some morning sessions, I've got some afternoon sessions, and I've also got some evening sessions. So hopefully one of those time slots will work for you. If not, then just shoot me a message and let me know that some other time is better for you, and then we can make arrangements for that. Please not one that's like 3 a.m. is the only time that works for me. I mean, if that's absolutely the only time that works for you, I'll see what I can do. But how about the rest of you? I need to go ahead and talk. I need to duck out of the frame for just a moment here. Got lots of finals. Too many cords back here. Hope don't blow a fuse. That would be bad. Let's see, plug in that one. That one's plugged in. Those are plugged in. I hope we're good. That's plugged in. That's plugged in. Let's see if I can do this over here. Sorry, I've got all sorts of stuff going. You're all in suspense, like, what is he doing? Right, let's try this, this. We'll see what happens. Hopefully I've done everything right. Find the switch that looks well. Here it is. Okay, cool. That is working. That's awesome. Okay, now I just got one more thing to hook up. Let's see, this, like that. Cords are not long enough. Sorry, you're all just watching me try to get all this stuff set up. All right, well that doesn't show up. Let's see. I gotta set that down. Sorry. It's like at the last moment I decided to do this and I'm looking at something on my monitor over here. Let's see, that comes out of there, that comes out of there. Well, that should be showing. Let's try to unplug this and plug it back in. Ah, there we go. Okay, I think we got it now. All right, I'm gonna turn off the music. All right, sorry to keep you all like bored. So,
It's okay. It's nice to have a break from thinking.
today is just kind of like a watch day. So, oh, I gotta duck out of the video again. So, as you can tell, I'm not like a young sprite like you all. Been around a while. You've probably actually seen me talk about this earlier in the semester. This time I'm going to show you again. So when I was growing up, back in around 1983 or so, my parents bought a computer. And this was one of the first personal computers that you could buy. This was the Apple II. Well, so there was the Apple I computer, which only a few of those were made. There was the Apple II computer, which was made from like 1979 through 1982 or so, 1981. And then after that came the Apple IIe, and the E stood for enhanced because it was like, it was a better version of the Apple II. And around 1988 or so, I sold that computer. Now, the Apple IIe, I think my parents probably purchased it for maybe close to $3,000, $4,000, which back in the early 1980s was a lot of money, obviously. And if you adjust it for inflation, it works out to be about $6,000 or $7,000 in today's money. So you can imagine that's a huge investment to buy one computer for the whole family. And then about a year and a half ago, I found one at a garage sale and I bought it. Someone was selling it for about $100. And so this is very, very close to the computer that I had back in the 1980s. And here it is. Right? Face for scale. Right? So, you know, by today's standards, it's a pretty big computer, but it's not that heavy. It's actually mostly air inside. So, you know, you'd recognize it's got a keyboard on it. You'd recognize the keyboard. There's nothing unusual about this keyboard as far as the letters or the symbols or anything like that. But it was a computer back then that was designed to be expanded. It didn't come with a disk drive. It didn't come with a monitor. It didn't come with anything that we sort of take for granted these days. You had to buy those things separately. So the computer itself was about $2,000, maybe $1,500. And then the peripherals, the things like the disk drives and the monitors, were all extra. I'll show you what the disk drives look like. Well, I'll show you more about that computer in just a moment here. But back in this box, back over here, I have, this is, I took this one apart, so I need to quickly snap it back together. So this is what one of the disk drives would have looked like. This is a floppy disk drive. It's got a little door on it, which you can manually open and close, and then the floppy disk goes in here, and it's got a single cable coming out the back that will go into the computer. Each one of these floppy drives was, I think, $500. So, and you needed two. So extra $1,000 just for your storage. What those floppy disks look like? They don't look like the ones you're probably used to, which are the little 3.5-inch drives with the door that slides on it. These ones, I have some back here. Here we go. So they would have looked like, they would have come in an envelope. You would have bought them in a box of 10, and then they're 5¼ inches in diameter. And they're called floppies, you know, because they're actually flexible. So are the ones that are the 3.5-inch floppies. Those are also flexible on the inside. So the floppy does not refer to the case on the outside. It refers to the media on the inside. So this has a disk inside of it about 5¼ inches in diameter. And what happens is when you put it into the disk drive, whoop, let me get one of those. When you put it into the disk drive, you slide it in, you close the door, and then inside, let me slide this cover off. Oh, I don't know if you can really see this. So here's what it looks like on the inside. So when you put the disk into it, like that, and close the door, you can see this mechanism right here comes down, and that clamps around that center portion of the disk, and that allows it to spin. And also happening, right there, can you see that closing? So also happening way back here is a magnetic read-write head is coming down and making contact with the disk media itself. Actually, the head is on the bottom. And so when you close the door, a little pad just presses the disk gently down onto that magnetic read-write head that's sitting on the bottom underneath the disk drive. Okay, so that's what the disk drives look like. Remember, each one of those was $500. You needed two. Generally, you needed two, so that would have been an extra $1,000 you had to spend on the computer. So already we're looking at $2,500 at least for the computer. The monitor itself, the monitor would have been a black and white, or maybe if you were really wanted to go all out, you would have gotten a color monitor, and those again would have run about $300–400. So we're looking at what, $1,500 plus $1,000 plus another $500 or so for the monitor, and we're looking at close to $3,000 there. And then of course you probably needed a printer. That was another maybe $600. So yeah, you spent a lot of money on a computer back then. Back to the computer. So you could very easily pop the lid off of this. No tools needed. And then inside, you've got a circuit board. This is the main board. Let's see, the processor is right there. That is a 65 6502 processor, 8-bit processor. And then right here is some of the main memory. It comes with 64 kilobytes. Okay, not megabytes, not gigabytes. 64 kilobytes of memory. The Apple II computer came with 16. Oh, sorry, it came with 48. And so the Apple IIe had a whopping 16 more. But you still couldn't do very much with the 64. So typically you bought a card that would go right here, an expansion board. The expansion board would have been just about the full length of the... actually I have one somewhere over there. I'm not going to find it right now. You could get another card. It was about this big. That had another 64 kilobytes on it. And then if you wanted even more, like maybe 4 megabytes or 8 megabytes, you got one that expanded the whole length of this. Right now, what you can do is there are hobbyists or enthusiasts out there who are manufacturing cards for this thing. And I'm trying to pull this one out. This is a 4 megabyte card, which you can get now for about 30 bucks. Back then, if you wanted 4 megabytes, that would have cost you about $1,000. So 4 megabytes. And it just fits in a little card right here. Slide it right in. Try to get it back in there. There. What else do we have in here? We've got a card that you would have attached your printer to. This one here is for attaching a modem, so you could call a bulletin board system or one of those services like CompuServe or the Source or Prodigy back then. And then here's the card that you would attach the disk drives to. And then on the back, you've got disk drive port, printer port, monitor output here, headphones, and a place to attach like a joystick. So this computer was really designed to be expandable. It doesn't come with a lot, but you could add all these other expansion cards into it, kind of like you do a PC these days. Although these days, PCs come with enough stuff on the back plane that you can just pretty much use the computer as is. But if you want to add more features to it or add more expansion or add more capabilities, then you added cards to the slots. Okay, so that's that computer right there. So that came out right around 1982, and then my parents bought one of those for the family shortly thereafter, 1983, I think-ish, somewhere in there. And that's the computer that I used all through junior high school and high school, and then I finally sold it at the end of high school because I wanted to buy a Macintosh, which had come out just a couple of years before that. And so my first Mac was the Mac Plus. I worked all summer to be able to afford that. I think I spent a total of about $2,000, maybe $2,500 on that. So I worked all summer. I worked 2 jobs so that I could afford to take that computer with me to college. But while I was in high school, the Apple IIe was replaced by another model called the Apple II GS. The GS stood for graphics and sound because it had better graphics and sound. And that is what I have right next to me here, what I was busy setting up when I was starting to stream. This is the computer that I wanted in high school. Like when this came out, I think in 1986 or so, everyone wanted this computer because it had all the expandability and all the nice, the ability to open it up and reach inside and work with the innards of the computer. But it also had enhanced graphics, enhanced sound, and a better monitor, a better keyboard, right? So it was just like a better computer. And I'm going to show it to you, and you'll say like, wow, it looks actually kind of like an old style Mac, almost kind of like that one that's right back over here. So you can see there were some design features of the Apple II GS that made their way into the Mac systems at the time. So I'm going to switch it off, and then I'm going to try to show this to you. Now my cables are really short, so I can't really do this very effectively. Oh, there's cables wrapped all around it. It's kind of ugly. Here we go. Let's see, I need to do, nope, not that one. What happened? This one? There we go. There we go. Okay, so this is like as far away from it as I can get. So this is obviously the monitor. Here's the bottom portion where you have the main board plus the expansion cards that are inside of it. This one came with enough expansion cards that you didn't really like need to add a whole lot to it, because it had a disk drive controller. It had enough memory in there. I think it came with 1 megabyte of memory, so it had, you know, plenty of memory at least to get started. It came with the ports to add the printer and the modem, so you didn't need those as well. So any expansions cards you got were just like extra stuff. And then over here, I've got 3 disk drives. Remember, the Apple II only had 2. This one had 3. This has a 3.5-inch drive, and then 2 of these 5.25-inch drives. Newer models, newer style. And then here's the better keyboard. Nicer keyboard. But again, nothing surprising about this keyboard, right? It's got all the same keys that you're used to, maybe just in slightly different positions, right? But here's the arrow keys. Here's the slash key, which normally is up here. Right? There's escape over there. All the normal stuff. So I'll go ahead and I'm going to reach back here and I'm going to turn it on. Oh, let me switch to this. Gotta find a switch. There we go. What are we looking at? Oh, we're just looking at a blank screen. Oh, there we go. My voice. So it says check startup device because there's nothing in the disk drives right now. Actually, let me go ahead and switch this back to here. So you can see it says check startup device. There's nothing in the disk drives. So what I need to do is I need to put a disk in the disk drive and then reboot this computer. So I'm going to put in, oh, actually, these computers, you didn't actually have to boot off of a disk drive if you didn't want to. You could just press reset and it would drop you straight into a place where you could start programming it. Let me go ahead and do that. There we go. So you see that little cursor right down there? I can start programming the computer right now. I won't be able to save any programs, but at least I can start programming it. So let me show that to you. Let me switch here. So this is basic programming. BASIC stands for Beginner's All-Purpose Symbolic Instruction Code. And you may have maybe seen a program written in BASIC. This is usually the one, remember, you know, in C and Java, you usually write your like Hello World program. This is Hello World in BASIC. I can do it in lowercase. Okay, so what did I do there? So the 10 is what's called a line number. Notice I didn't bring up an IDE where I have an editor and a place for me to compile and run the program. I just simply type in the program. And so in order for it to keep track of where each line of code goes, you prefix each line with a number. And that tells it where in the sequence of instructions that particular line is going to go. So typically you'll start your program at 10. There's no rule that says you have to start at 10. You could start at 1 if you wanted to. You could start at 100. You could start at 50. Doesn't matter what you start at, but typically you start at 10. And then print would be recognizable to anyone who's programmed in Python or even Java, right? In Java, it's system.out.print, but in Python, it's just print. And then in double quotes, you just put what you want to print. And then in order to execute or run the program, you just type in run and press enter, and then it executes the program. If I want to see the listing of the program, I type list. There it is. And let's see, let's get it to print something else out. So I want it to print maybe good morning right after it prints out hello world. And so in order to do that, I need to add another print statement that comes after the first one. And so maybe I'll pick line 20. Oh, I've goofed. Let's try that again. 20. I accidentally hit the down arrow key. now I can see that I've got a line 10 that says print hello world and a line 20 that says good morning. And then if I run the program, you can see they appear one after the other. So the third thing I want to show you is, like, maybe I want it to put something in between hello world and good morning. I want it to maybe say, I don't know, welcome to December, or something like that. So I need that to appear after line 10, but before line 20. So I need to pick a line number that comes between 10 and 20. Maybe 15. And you can see that it has inserted line 15 in between the 10 and the 20. So just by choosing a line number that is a number in between the two that you want to insert between, it has gone ahead and put that line in between those two line numbers. So that's why typically you'll see basic programs have line numbers that increment by tens, is so that if you as a programmer decide to add some new lines to the program, you've got to have numeric space to be able to put that in there. The question is, how do you correct a line? Well, you retype it. So if I want to change line 15 to, instead of saying welcome to December, I want to say goodbye November, I just have to type in 15. And then the new line, and then it just replaces the old line 15 with a new line 15. So what does that kind of imply? First thing it implies is that double check your work before you press enter. So if you need to make any corrections before you press enter, then you go like, well, now I don't have to type that whole line again. Or if you do find a mistake, and then you go, oh, man, I got to type that line again. So you tend to make your lines kind of short. It wasn't long before some developers came out with some utilities, some tools that you could use to do things like edit a line. So you can maybe press a couple of keystrokes and say, I want to edit line 15. It would then bring up line 15 for you to use your arrow keys to move back and forth and insert some new characters or delete or change some. But in its mode right now, it can't do that. So the typical beginner's program would be to do something like print hello or print out some more disgusting word, and then maybe loop that to get it, just do that over and over again. So I'm going to erase this program. New is the word you type in, and now there's nothing there to look at. And so we could say 10 print, I don't know, goofball. And then you could say 20 go to 10. So when it runs this program, it'll execute line 10 by printing out goofball, and then line 20 says go back to line 10. And then it just scrolls like that. I can press, I think it's Control-C, and then that'll stop it. Control-C is the same control sequence you press, like on a Linux or a Unix system, to stop it from scrolling indefinitely. What if you want to add a line between 10 and 11? Well, then you're stuck. So there's a couple things you could do. You can put more than one statement on a line. So if I just want to add one little thing in between line 10 and 11, what I might do is just replace line 10 with a new line that has both those statements on it. So let's say I had no space in between line 10 and 20. Let's say it was line 10 and then line 11, and I want it to print out, goofball, and also maybe print out something else. So I could say 10 print goofball, and then a colon is used to separate statements on the same line. Oh, let's do this. Let's do character $7. Okay. Now, Python programmers might recognize CHR as being a function that converts an ASCII value to its text value. So in this case, character $sign means I want to produce a string as a result. So what I'm doing is I'm feeding in ASCII value 7, and what that corresponds to is Control G on your keyboard. Control G will make the computer beep. If you look on the ASCII table, ASCII value 7 is called the bell character. And it would have been used in the old days to make your teletype ding a bell when it got to the edge of the paper, so you knew to go to the next line. Or typewriters had a bell in it to let you know when you were getting to the edge of the paper. So let's go ahead and run let's list it. So you can see it's going to print out goofball and then also print out a bell, which will make it beep. Can you hear that?
This is pretty cool.
So you can see all sorts of hilarity would ensue if you had a whole bunch of these in a classroom. So some enterprising kid would go and type in a program like that, and then go and run it, and then quickly leave the room. And if you had a whole lab full of these things, like 20 of these computers, which back then would have cost what, $50,000. You type in those programs, set them running, and then go and make your hasty exit. Okay, so let's say you want to do a little loop. Let's do this. I want to make an asterisk or something like that go zigzagging across the screen. So let's do this. Let's go. Let's see, how am I going to do that? So first of all, anytime I run the print statement, it just causes the line to scroll up one line, and then it prints out what I want. So basically, in order to make this zigzag line, all I've got to do is a whole bunch of prints. So I'm going to print some spaces, and then an asterisk, and then go to the next line. Or I can use a command in BASIC called htab that tells it to horizontally tab the cursor over. That could replace just running a loop to put a whole bunch of spaces in. So we got 40 characters wide. So let's go 10 for I equals 1 to, I think we have to do 39. And then 20, we're going to h-tab the value of I. And then 30, print my asterisk. And then line 40, next I. So that's how you do a loop. You recognize a for loop. It looks a lot like the for loop for, well, actually it doesn't look like anything like the for loop for Java or Python. But basically that's how you do a loop. It counts from 1 to 39. And then we have horizontal tab over I characters. So either 1, 2, 3, 4, up to 39. Print your asterisk, and then it will go to the next line and repeat this over and over again. Oh, you see that? Zip, goes across. Okay, now if I want it to zigzag back and forth, I've got to run another loop that now counts down from 39 back to 1. So line 50 for I equals 39 to 1. Line 60, h-tab I, and now I'm just going to put the print on the same line, since those kind of go together. And then line 70, next I. Take a look at our program. Good, and let's run it. Oh. Okay, so here's kind of a problem with, I think what's happening here is, so BASIC is an interpreted language, which means it's not compiling the program. It's just running the program a statement at a time as it's going through the listing. So the first line there was a loop that says loop the variable I from 1 to 39, and then do the horizontal tab of I, and then print out the asterisk, and then that statement that says next I means go back up to the top of the loop and do the next iteration. So that one worked fine. It made the asterisk zip across the screen going in a diagonal line like we want it to. But then the next loop says for I equals 39 to 1. Oh, I see what the problem is. So the problem is actually not what I thought it was. The problem here is, by default, the loop counts upward. So you give it the beginning value, the ending value, and it normally gets from the beginning to the end value by incrementing by 1. The problem is my ending value is less than my beginning value, and so it doesn't know to go the other direction. So I need to change the loop. So I want to start at 39, go to 1, but I want to increment by -1 each time. That's the problem. So I have to replace that line, 50, for I equals 39 to 1, step -1. That gets it to go backwards. Now, how can I get it to just zigzag back and forth indefinitely? What do you think I should do?
You can do just go to 10.
Yeah,
Yeah.
just have it repeat the whole program over again. So line 80, go to line 10. So you're getting it.
Disappointed in your lack of bells.
Well, we can add one in, right? After maybe on line 45, we can print character $7.
Oh, I love it.
Maybe 75, do the same thing. Now, one thing I've just noticed in myself is that every time I make a change, I type list. And that is leftover finger muscle memory from the 1980s. When every time you made a change to the program, you sort of instinctively typed list. It just took a quick glance at it to make sure it got inserted in the right spot and it looked okay.
I notice it prints a blank line when it does the bell.
Oh, that's because print normally does a new line character when it's done doing the print. So it goes to the next line. If we want it to not do the new line character, we have to put a semicolon at the end of the print, and that means don't put the new line.
What if instead of 7 we did I?
Okay, well, let's make this change first. Print character $I, and let's put the semicolon on the end, and let's do the same thing for 75. Print character $I. Well, the problem is that I has the value 39 when it gets done with the loop, and I also has the value 1 when it gets done with the other loop. So I don't know if you can see it, but there is a parentheses scrolling by. There, you can see it there. And so that parentheses probably has the ASCII value, well, either 39 or 40, depending upon what the value of I is. Why don't we do this? Let's try out something here. I'm just going to erase this program. See how easy it is to just blow away your whole program? Let's go 10 for I equals 1 to 250. Let's do 100, yeah, 255. 20, print, character $I, semicolon, 30, next I. So it's going to loop from 1 to 255. That's the whole ASCII value range. And it's going to print out each character as it goes. And then let's end it with a final print, just so it goes to the next line. So you've got pretty much the whole ASCII value, ASCII character set there. And you probably heard it beep in there because one of those characters that printed out was the beep. You actually heard it beep twice because when you go from 1 to 255, the ASCII values get repeated again. The ASCII values are actually only valid from 0 to 127, and then they repeat again essentially from 128 up to 255, at least as far as the Apple goes.
It doesn't have the extended? No.
No, not by default. But I think probably if we boot it into an operating system and run a different version of BASIC, it'll work differently. So let's try that. So I have here a diskette that's got ProDOS, which was a disk operating system back in the 1980s. And I'm going to put that into the disk drive. And you can reboot it just by holding down the Apple key, and then a control, and then press the reset button. And Apple users, Mac users might recognize that as being the exact same character sequence, almost the exact same character sequence you do if you want to force quit one of the applications that are running. Oops, let's try that again. There we go. Uh-oh. Why did that happen? Let's try it again. Huh. Let me look here and see if I have another copy of that. The problem with these old disk drives is the disks themselves are 30 years old, almost 40 years old, and they're just falling apart. So I wanted to see if I had another one of those sitting around. Let me look in this other disk drive bin. And the other problem that could be happening is the mechanisms themselves are getting old and they occasionally need to be cleaned. I don't know. I can't find one right now. Maybe it's not worth doing at this moment. I'll tell you, there is a way I can find out if it's the disk drive or the disk, and that's just try to boot a different disk. You're having fun looking at that, right? So, I don't know. It could be the disk drive needs to be cleaned because it's just got some built-up dirt, or it could be that this particular diskette has just had its day. I just need to make a new one. The question is like, how do you make a new one if it doesn't boot the disk drive? Well, I can find another one that boots somewhere. But what you probably all came for me to do is play games, right? That's what you came here for. Let's see if that'll work. I've got a disk drive here, or a joystick here, not disk drive, a joystick. Got to plug it into the back of the computer. So I got to disappear again for a moment. You wouldn't believe some of this vintage 8-bit stuff goes for a pretty penny these days. I think, you know, I bought a lot of this stuff like at the beginning of the pandemic, and as the pandemic has like progressed along, this stuff has actually become more valuable. As you know, some people get to their middle ages and they buy sports cars or they buy, you know, expensive golf equipment. I just buy old computers. Let's see if this one works. Oh, that one's working. So it must have been the diskette itself has gone bad. So this is probably what was one of the best games at the time. I wish I could feed the sound right into the...
I think we can hear it just fine.
Oh, why did I fall off?
That was awful.
Oh, the problem is my joystick here is not calibrated. So the joystick's not calibrated, so it immediately like thought I was going to the left. Oh, the other problem is, hold on, I need to like fix this here. Let's see. What do I do here? Is it this one? Here we go. Control panel. System speed. Let me slow this thing down. Normal.
Oh, wow.
Normal.
I remember having to do this.
You had to do this?
The games would run too fast.
Yeah.
Is it based on the clock speed?
Let's see. Is that all I have to do? Quit. Quit. Nowadays, the games just have a timer in them to make sure they run at the same speed no matter how fast or slow your computer is. But back then, they didn't have that. They all ran basically at full speed. And so if you had a faster computer, the game would run faster. Oh, hey, why is it going backwards? Yeah. Maybe I should play this with the keyboard. So this joystick has a little adjustment dial on here, so you can adjust where center is for here, and I think that it thinks that it's actually not centered. Boy, this is interesting, right? Watching me do this.
I like that the game fully just ends when you die.
Oh yeah, you only get one life in this, just like real life, right? You get one life, that's it. Please don't go backwards. Why are you going backwards? Maybe I have to swing this all the way to the other side. Here, I know what I could do. Here, stop this. Stop. There we go. A little basic program. Let's see. 10. Print. I think it's paddle 0. comma, paddle 1. Does that work? Yeah. And then 20, go to 10, run. Ah, see? So what I'm doing is I'm getting it to print out my XY values, and it's just coming out to be 0, and 0 is like left. So what's going on here? Maybe this is not fully seated in here. Is anything happening on the screen? No. You know, actually, I bought this joystick from someone who's selling it, and this is the first time I'm using it. So I actually honestly don't know if it works. It could be it needs to be cleaned or I need to open it up and figure out what's going on inside of here, why it's not working. So, given that that didn't work, I will use this older one that I know works. I'm pretty sure it does. I'll plug this in. Are we getting numbers? No. All right, well, maybe I can't show you games. Although I have done this before. Of course, the other question is, am I putting it into the correct port? I've got to be, because there's only one that's shaped like that. Oh, the other thing is, let's try it. Is it PDL? Oh, it's not paddle, it's PDL. Ugh. All right, let's try this again. 10 print PDL 0, comma PDL 1. There we go. Look at that. So now as I move this joystick around, the numbers are moving. So if I move this to the left, I get 3. If I move it to the right, I get 255. That's good. Up. Now the other one's changing. And then when they're right in the middle, it should be approximately like 128, 127 to be the middle. There, like that. Let me try the other one. Actually, I'll just use this joystick since we know it's working. I'm just pressing spacebar to get past all the title screen stuff. All right, now this should work. I think we're in business here. So the triangles on the left, those are my that's my life, or my health. All right. I'm gonna walk along here, and I've got to fight this guy. And so I can press one of the joystick buttons to do a kick. I can move the joystick down, and I can do a low kick. I can do a high kick. Oh, I got punched. This is the easy guy too. Oh, and the other button does a punch, right? So I can. I've almost got him. One more. There we go.
I like the cliff now because it prevents you from just abusing back pedal.
What's that?
The cliff. It's so you can't just walk backwards indefinitely.
Yeah.
I like that choice.
I'm running. So what I have to do is I have to stop running at exactly the right moment. Because if you're running while they punch you, you're dead. I just love these wonderful sound effects. I mean, back then these were great sound effects, but now, like, where's the background music?
Can't handle that at the same time as fighting.
Well, also the sound it could play was really limited. Basically just tones. So you play this game, and one of the funny things that happens is you ultimately discover that you're supposed to be rescuing a princess, of course. And you get to the final room where the princess is, and if you come running into the room, she gives you a punch right to the neck and you die. So you're probably wondering, if I don't have one of these old computers, how can I play these games? And there are actually websites that run emulators. I can show that to you in just a little bit. So the emulator, because this computer runs at a whopping 1 megahertz, so it's roughly 2,000 times slower than your current computers. You can absolutely run an emulator in your browser. It just runs JavaScript. The whole emulator is just a JavaScript program. And so you can play these games in an emulator. Of course, you don't have the joystick, so you have to use the keyboard controls. Now, I'm pretty sure I have to sneak along here. Yeah, because he just appears right away. You can see as you move along, the opponents have more health and you have less and less. I pretty much just do the kicks, or yeah, I can do punches, I guess, but almost got him. One more. So you basically just defeat these guys until you get to the gate. So however many guys it takes to get to the gate. So if you don't go running towards the gate, then you just end up having to fight more and more and more guys. And each of them gets stronger and stronger. And at this point, my thumb is getting weaker and weaker because I'm just hitting that button as fast as I can. I'm going to die. So when you get down to like these lives here, you can retreat at that point and you can get some health back. But of course, your enemy is also getting his health back. And you're getting further away from the gate. I might as well just die. Get this game over with. Oh, maybe I can get him. Ha ha ha. Oh, I got one more guy. That's enough of that. Familiar with this game?
Sounds familiar. Didn't see that.
Back then, a lot of these games came copy protected, so that you couldn't just make a copy of the disk. And so some enterprising people go around, but they basically do is they figure out how to break the copy protection on the disk drives, on the diskettes, and then they usually put their name on there. Let's see. This is called Lode Runner. The goal is to get all the way to the top. Oops, that was the wrong button I pressed. This game I played over and over and over again. Oh, so that was the last one. That means one of these guys has one of those things. Nope. Come and get me. Nope. Nope. There it is. Next level. This was one of my favorite games when I was a kid.
Yeah, I like this one better.
See, I can jump through the holes. They get stuck in them. So the goal, as you can see, is to pick up all those little square things. Once you pick up the last one, then the last ladder appears. The guys aren't very smart, but they do each have their own personality. So how do we get this one? All right, so you do this, you do this, you jump in, you do this, you come in. That's it. I got the last one. Oh, there's one of those things there. It's a transparent brick. Let's see. So how did we do that? I'm not going to remember how we do that. How do we get... So I fall through that. Oh, I see. We're not done yet. There's still a couple of them left. Uh-oh. Oh. I didn't drill a hole in time. Get that one. Drill, drill, go in, drill, go in, drill. You can see I'm a compelling Twitch streamer. Oh, so there's one. Is there one more somewhere? Ah, there it is. There we go. This one, it came with, I think, about 100 levels, and then you could buy expansion packs, which we would call now DLCs, that had more levels on it. And it also came with a level editor, so you could make your own levels. Okay, now I gotta get that last one, I think. That should be pretty easy. There we go. Easy cheesy. So that's Lode Runner. Oh, let's see. Nah, I'm not going to play it. That was one of my favorite games. So, yeah, those two favorite games. Pac-Man, Mario Brothers, Archon, which was a chess game, Winter Olympics. Oh, that'll be a good one to play like in a couple months when the Olympics begins. Lemonade Stand, Donkey Kong, Oregon Trail. Probably heard about that one. All right, enough of that. I'm gonna have to fix this diskette. Figure out what's going wrong with this one. Why is this one not working? Probably just have to make a new one. And then I also have two diskettes here, which are Apple Pascal. If you didn't want to program in BASIC, you could program in Pascal as well. And I also have a C compiler for this. I haven't used it yet. So booted two diskettes, and then one of these had the compiler on it, and one of them had the editor on it. That was the programming language. After I learned BASIC myself, I took a course in high school where you learned Pascal. And that kind of started my whole programming career right there.
I'm jealous. My high school had one programming class, and the guy that ran the IT department wouldn't let us actually code.
Oh no! So what'd you do?
Wrote things by hand on grid-lined paper.
And that's how you did programming?
And that was it. That's all we learned.
How terrible!
Yeah, he was afraid we'd learned how to hack and then mess up the systems of the school.
Oh, because he was the IT guy, you said, right?
Yeah.
All right, so if you want to try this out yourself, there's a couple things you can do. You can always go to archive.org, and they have been collecting all of these old games and software. Let's do a search here for, let's see, can I do vintage software? I guess that one. Let's just do a search. How do I make it actually search? Pressing enter doesn't do anything. Oh, search this collection. Let's try that. What's going on? It's like my keyboard's not working. Oh, there it goes. Lode Runner for Macintosh. I'm looking for Lode Runner for the Apple. You can also do Lode Runner for the Commodore 64. You can do it for old PCs. And that's all vintage stuff. Boy, it's being slow. The other thing you can do, well, that's searching over there. I'll come over here. And is this one? Okay, so here's that emulator that runs entirely in JavaScript in your browser. So we could pick a disk. Well, they got a whole bunch here we can pick from. Let's pick like games. Look at all these games we can pick from. And then we'll hit reset. Oops, you have to do control reset. Open Apple, control reset. There we go. So let's see, to enable keyboard controls, I think you do Control K for keyboard. And then, yeah, L is left, I is up, J is right, or sorry, L is right. So you're doing a little like WASD, but you're using I, J, K, and L. WASD was not yet to come for many years. So you're probably wondering, why didn't they use WASD? Because that just wasn't a thing back then. And then to drill, it's U and O. So everything's like right there on your right hand. I'm missing one of those boxes. Where is it? Oh, there it is. Gotcha. Okay, so if Lode Runner is not your thing, then here's that other one. There's a whole bunch on here. You can do programming. You got logo, Pascal, Forth, graphic stuff, blank disks. Someone wanted to see if we do 10 for I equals 1 to 255, 20, print character $ I, semicolon, and then 30 next I, run. Uh-oh. Syntax error in for I equals 1 to 255, that looks good. Print character $I, semicolon, that looks good. Next I. Anything wrong with that?
Earlier you were putting a space before the semicolon.
Shouldn't matter.
I don't know if that matters. And then you have maybe 2 spaces after print. Does that matter?
That's just the way it's displaying it. I don't know. Looks okay to me.
Don't you have a space after the $ in this one?
That's just the way the listing is printing it out. So even though I type it in without the space, it goes in there with the space. Huh, that's weird. Let's do this again. New. For I equals 1 to 255. Now that's weird. Huh. I don't know what's going on. Oh wait, I think I do know what's going on. Hold on, let me switch this around. 20. No, sorry, 10 for I equals, let's not start at 1, let's start at 32. So let's go 10, that's good, for I. So what happened there is, since we're running under ProDOS, which is an operating system, this is kind of like a weird artifact here. We've got the BASIC, which is built into the computer itself, and then we've got ProDOS, which is layered on top of that. Well, ProDOS adds some commands to BASIC. It adds commands for saving files, opening, closing, reading, writing, all the usual file system stuff. But because those are additional commands, the BASIC needs to know, when am I running one of my internal commands and when am I running one of these new DOS commands. And so what you do in your BASIC programs, if you want to run one of the DOS commands, you have to print the ASCII character number 4, which is a control D. And that tells it the next thing you're going to see is a DOS command. And so that's how it could tell whether it was running an internal function, internal routine, or one that was added on. And so what's happening is, because I'm running this loop from 1 to 255, one of the characters I'm printing out is character number 4, which tells it the next thing that you're going to see is going to be a DOS command. Well, the next thing it sees is like character number 5, and that's not a DOS command, and that's why it says syntax error. That's not a DOS command. And so by making my loop start at 32, I bypass all of those control characters that are occupying from 1 to 32 or 1 to 31, and I start at 32, which is a space. And then I got the syntax error again because, remember, that ASCII character set loops around and it comes back again to, what is it, 132, which is another control D, and then again it gets a syntax error. So, I mean, I guess one thing I could do is I could still run this loop from 1 to 32. Let's go ahead and do that. For I equals 1 to 255. Okay, but now let's do like on 15. Let's go if I is equal to 4. Next I. Okay, so if I encounter a 4, I'm not going to print it. I'm instead just going to roll to the next number. Oh, let's do 15. If I is equal to 4, then next I. There we go. So you see how it basically skipped over number 4, and it allowed me to just go ahead with the rest of my loop. And then I got to do the same thing again. Let's do line 16. If I is equal to 128 plus 127 plus 4. Let's see, 128 is 0, 129, 130, 131, I guess 131. Nope, I don't think I got that right. 16, if I is equal to 132, then next I. There we go. So now we successfully printed out the ASCII character set twice. You could also change the look of the characters. I could go into inverse mode. Oh, that didn't work. Inverse. I can do normal. And I think I can do, is it blink? No. There's another mode where the characters blink at you. I don't remember what that's called. No. 40-year-old memory is failing me about how to make it blink. Anyway, so you can run these emulators entirely in your browser. You can also download emulators to run on your computer. The nice thing about these emulators in the browser is you got all these software that you can play with. So remember, to reset the computer, you do the Apple over here, a control, and then a reset. And that reboots the computer. And then if you just want to stop the computer, you can do control reset. Oh, well, I stopped in the middle of loading. So that's not going to work. Oh, let's take out the disk here. Can I do that? How do I eject? Eject? That one. No? I don't know.
I know you've moved on, but I think the command you were looking for was flash.
Flash.
Maybe, according to some quick Googling.
That sounds about right. Okay, well, we've kind of reached the end of what we would usually do. Do you want me to keep going, or are we done? Oh, I guess I can show you one more thing. So the Apple IIgs, as I said, had enhanced graphics and sound. It also had more memory, so it could do more stuff than the old Apple IIe could. And one of the things that was added on in the Apple IIgs was a windowed operating system, you know, kind of like you'd recognize today. So you would normally load that off of your larger capacity 3.5-inch floppy disks, but you'd still have to use maybe 2 of them and exchange the floppy disks. These days, there is a solution. Again, some of these enthusiast hobbyists have come up with a card you can put into one of the Apple II computers that will make it boot off of a flash drive. It treat the flash drive as though it was a disk drive, a hard disk, if you will. And so that's what I've got here. Is I've got a little USB flash drive, and then I've got a cable that runs into the computer. And I should be able to boot off of that. Let's go ahead and get this to boot. Oh, is it not working? Oh, there it goes. And then to be able to use this, I'm going to need a mouse. Now, this is one of the old style mice. This one had a little ball on the bottom. So it's not an optical one. This one actually has a little ball. And so when you put it on your pad, that ball rolls around. I can't tell if it's gotten stuck. Possibly because I plugged something in while it was doing that. It's probably unhappy about that. Let me just turn this off. So I think what happened was I plugged in the mouse while it was booting, and so the mouse is not like a USB mouse where you can just plug and unplug it and plug it in anytime you want. This actually plugs into the side of the keyboard using a different bus technology called Apple Desktop Bus, and I'm thinking it froze maybe at the moment I plugged it in. And so I'm thinking it was not pleased about that. On the other hand, is it frozen at the same spot? Let's see if this comes up. This worked the last time I did it, but that was like many months ago. Ah, here we go. It's working. I don't have a whole lot loaded on here, but you'll see this looks like, you know, it's familiar, at least if you use a Mac. Right? Got a file menu, edit, a Windows menu, view. You can initialize and erase your disks. You've got your special menu for doing shutdown, changing colors of icons. So like I said, I don't actually have a whole lot on here because I haven't gotten around to it. But we can run this and we can drop into BASIC. You know, then we're back into BASIC, right? And let's see, how do I get back? Is it by? There we go. You see how painfully slow it is, right? Oh, and we're also running the system at a slower speed. I have to go in the control panel and speed it up to its normal speed. I did that slower speed so that we could actually play the games. But this one over here, this total replay, is a hard drive image that contains about 200 or 300 games that you can play. So I'm pressing the arrow keys, and you can scroll through like all of these games that are loaded onto this hard drive image. I'm still on the A's. Now, how can it have so many games? Well, most games fit on a floppy disk, and the floppy disks held 140 kilobytes of storage. 140 kilobytes. That was a standard 5 1/4 inch floppy disk. So on a hard disk, and the maximum size of the hard disk back then was 32 megabytes. Not the gigabytes, not terabytes, 32 megabytes. But still, you could hold hundreds of disks worth of information on one hard drive. But this doesn't use hard drives, it just uses that USB device. And so there's basically a emulated hard drive on that USB flash disk. All right, so this is great stuff. Right, all these games on here. You don't have to scroll through them one at a time. You can hit like the T key, and it goes to the T section of all the games. Okay, so let me show you. Let's see, we'll do this here. Is it that? I guess we'll do that. I need to clean that disk drive. It's not working. Oh, I can hear it. It's going. That's the nice thing about the disk drives. You can actually physically hear them going, and so I can hear I can hear them clicking away, but I can also hear them resetting themselves. So I probably need to adjust and clean that disk drive. So let me try one of these other floppy disks here. We'll do this one. You come out, you come out, you go in. No? Come on, you can do this. Oh, let's do this. We'll do PR number 5, which should tell it to boot off of. That didn't work. Do I have this plugged in? Let's see. This goes into here. That it should be plugged in. That goes into there. That goes into there. Let's do this. How do we get that control panel? See what we got here. Slots. Smart port. There, that's fine. No, it's not booting off of port 5. So this is how you get it to boot off of another disk drive that's got a card in the slot. So this should boot off of port number 5. I'm not remembering something. Let's go back into the control panel. So everything is its default. Let's see, we got display, sound, system speed, clock, keyboard, slots, printer port, modem port, RAM disk, mouse, quit. That should be it. I'm not remembering something, so let me do a quick search here. Apple IIgs boot from 3.5-inch floppy drive. So this says in a drive chain. So I got the floppy drives plugged into each other. So the 3.5-inch goes into the computer, and then one of the 5 1/4 plugs into the back of the 3.5, and the other 5 1/4 plugs into the back of that. And that's the way it's supposed to go. Let me just double check. So this cable goes into the computer. That's correct. And then that's first, and then this one goes into there, right? And then this one goes into there. It's all correct. Oh, now it's going. Maybe the cord really wasn't plugged in that strongly. I know, 1983, wasn't born yet, right? So this computer's older than you are. Okay, so this was a Pascal system. So you come up to the main menu here, and we want to create a new program. So I'm going to go into the filer by pressing F. And I think I press N for new. Good. And then I quit. And I go back to the main menu. And now I go to the editor by pressing E. Edit what file? I'm going to press return for a new file. And now I'm in the Pascal editor. Now Pascal predates C and Java, although it postdates BASIC. So what you're going to see is something that looks probably unfamiliar to you, but nevertheless set the foundations for the languages that came later, like Java and C and Python. So I'm going to go into, now the editor, of course, is just so I can type in the program. This is not Pascal itself. Pascal is what I'm going to type in a moment here. But I'm going to press I to go into insert mode, and then I'm going to go program. Let's call this hello. And I think I have to put a semicolon at the end. Pascal was the programming language that set the stage for semicolons being at the end of statements. And then begin, semicolon. And then we're going to, of course, we're going to indent, and then we're going to use write line. Java uses print line, but Pascal used write line. And then strings in Pascal go inside of single quotes. And then when your program was all done, you put end, period. So a period marks the end of your program. Now, so you may be wondering, like, what's the deal with the semicolons? Like, here's what the semicolons mean. In the English language, if you have a list of things that you need, like let's say it's a to-do list, a list of things you need to do, normally you would put commas between them. You'd say, I want to, do the laundry, comma, take a bath, comma, feed the dog, comma, eat lunch, period. But if your list of things to do includes lists themselves, then the English language says you use semicolons to separate the items of the list. For example, if I want to say, feed the fish, comma, cats, comma, dog, semicolon. Eat lunch, semicolon, right? So you use semicolons to separate the items in a list when the items themselves might contain commas. Otherwise, just use commas. And so that's why we use semicolons to separate the statements in a program, because you're essentially saying, do this, semicolon, do this, semicolon, and the things that you're doing might contain commas. You know, they might contain commas because you've got maybe a couple of variable declarations, integer x comma y, or maybe you've got statements for where you're passing values into a function and use commas there to pass the values in. So the reason why we have semicolons is because we're separating the statements in basically a list of things to do. Now, depending upon who you listen to also, the English language says that the very last two items, you just put the word and in between those last two items. And some people say you put a comma in front of the and some people say you don't put a comma in front of the and. So it depends upon who you learn from. You either put a comma for the last item or you don't put a comma for the last item. In Pascal, they follow the latter one, which is you don't put a semicolon on the very last thing you do. All right, it's kind of weird, right? So I've got a semicolon on that write line statement there. I actually should not put one there. If I'm remembering this right, I may not be remembering this right, but I know that in Pascal, if you have a list of things to do, you do not put a semicolon on the last one because it's the last item in a list, right? You don't put a semicolon, you don't put a comma after the last thing in a list of things to do. You put a period there. So I think I need to press escape. Uh-oh. I didn't save what I was going to do. See, it says there, Control-C accepts what I type in. I just hit escape, and that just erased everything. So let me try this again. Program hello, semicolon, begin. I'm trying to remember if I do a semicolon after begin. Well, we'll try it without there. We'll try it with one. Right line, hello, semicolon, and then end, period, and then Control C to accept. All right, now it says here, I'm going to press Q to quit. To leave the editor, type E to exit the command line. To store the file, type W to write, or U to update. We're actually going to do U because we're just going to save it to the file that we've already created. So it's now going to save. And then we exit to the command line. And then we're going to compile, press C. And this is where you wait for a while. So normally, on your Java programs, you would just press a button to compile it, and it would be done in like, a fraction of a second. Now the compiler's running, and this takes a few seconds to do it. It has to load the compiler into memory. And it compiled. So I actually got that right. And now we're going to run. And it says hello, and the program's done. Let's go back and edit. So I pressed E. Okay, so all statements have to end with a semicolon. So program hello, semicolon, and then begin, semicolon, right line hello, semicolon, and end is also a statement, so that gets the period at the end. So you wouldn't put a semicolon there, you put a period, because it's the very last one. There's only one period in your program, and that's at the end, it's at the very bottom. Semicolons everywhere else. So let's get it to do hello a few times. So I'm going to go into insert mode, and let's see, how do we do loops here? We do for I, now I got to look this up. My Pascal syntax. Pascal has gone like out the door. Of course, back then we didn't have Google. You just had a book that you had to use. You had to go look it up in a book. I'm looking at this Pascal examples. Pascal Loops. Okay, we got a for loop. Oh, here we go. For I colon equals 1, 2, 10. Do, semicolon. Oh, it's just do. And then Control C. Let's put a couple spaces in there. And then, and then insert. Begin, semicolon. Nope, I don't want that. See, this editor is an old editor, and so I have to get used to again to what all the commands are. So what I do is I want to get rid of this indent here. So I need to do that with delete, adjust. Let's try delete. Delete? No. Adjust. Left. Oh, that'll work. There we go. Control C. Right line, this thing here. And then we'll go insert. End. No, is it end? Yeah. semicolon. Okay, so we're going to loop I. Now in Pascal, the way you assign is colon equals, and the way you compare is just equals. And contrast that with Java, in which assignment is a single equals and comparison is two equals. So it's a little bit different. Now, I don't think this is going to compile, but we'll try it. Quit, update, return. No, I didn't want to return. I wanted to exit. Quit, update, exit to command line, compile. Aha, that's what I thought was going to happen. So let's go back into the editor. We'll press E. Okay, so what happened there? Undeclared identifier. Oh, I didn't declare my variable. So I need to go back over here, and I'm going to go insert, var I colon integer, semicolon. So I need to declare my I variable to be an integer. Quit, update, exit. I can actually just hit R for run. It'll compile it and then run it. Okay. Ooh, another error. And another error. So let's go and edit this thing. What did I do wrong? Data types, variable types. No, I got that right. Var, oh, does that have to be on a separate line? So basically what we're doing is there's the variable declaration section of the program, and then there's the, oh, and that has to go, yeah. So there's the variable declaration section of the program, and then there's the actual code that it does. And so the variable declaration has to go above the begin. So it's not like in Java where you can just declare variables anytime you want. In Pascal, you have to declare your variables up before you actually run the code. And then once you do begin, that's the code that actually is going to run. So all your variables need to be declared by the time you get to that point. So that means we need to come up here and we need to delete that, and then come down here and insert begin, semicolon. Did I do this right? So var begin, let's insert that, and let's come over here and insert there. I guess, oh, yeah, I see. And now I'm just being a stickler for this, right? Adjust, left. I'm just getting my indentation right here. Adjust, left, adjust, There. That looks better. Quit. Update. Exit. Run. Oh, it's going to compile. Yay. Whoa, it printed out hello 10 times. Oh, it's the little things in life, right? So in a Pascal program, you got your variable declarations. You've also got your type declarations. If you want to build anything like a struct, in C they're called structs. In Java, it'd be like basically a class. And in Pascal, it's called a record. That allows you to put multiple things into one thing. We can also do arrays. In Pascal arrays, you can pick your own indexes. So in Java and C, the arrays always begin at 0. In Pascal, you can say, I want to make x be an array from 10 to 50. And then the first index will be 10, and the last index will be 50. I know, is that crazy? So you can pick your own indexes for your arrays. What else? It does have pointers. And it's got functions and procedures. What Pascal doesn't have is classes. That's something that was added on later on with languages like Simula, Modula 2, and then finally C++ and Java added the object orientation. But Pascal itself was not object-oriented. The way C is not object-oriented. You basically got your procedures and functions. The difference between the two of them is a procedure just does something. It doesn't return anything. And a function always returns something. So procedures can accept parameters, but they don't return anything. And functions accept parameters, and they do return something. So when you write a function, you must return something. And when you write a procedure, you cannot return anything. Okay, so that was basically Pascal. And so as you can see, the edit, compile, run cycle takes about a minute or so to do, even if you have one small change that you need to do. So that kind of changes the way you approach programming. It's do more editing, do more syntax checking in your head. Don't rely so much on the compiler, because it just takes forever for the compiler to get around to your syntax error. So take a look at your program. Make sure it looks as good as it possibly can, and then run the compiler. And then wait for it to compile your program. And then wait again to be able to run your program. So you don't have this tight little loop like we have right now in C and Java, where you can edit and run and compile in like less than 5 seconds. Now it took at least a minute to do one complete cycle. What else? Oh, I showed you some games. I showed you some basic programming. I showed you some Pascal programming. What else is there? I can't really open it up and show you what's inside because I have a monitor stacked on top of it, and the monitor is kind of heavy. You know what's crazy is, like, this is an old CRT monitor, an old cathode ray tube monitor. Actually, I can switch over here a little bit and show it to you. I think that's this, yeah. And these lines that you see going up, I don't actually see those. That's caused by the refresh rate of the CRT not matching the refresh rate of the camera that I'm using. So I don't see these lines going up and down. But the CRT, as you can see, is this fairly deep device. And it's putting off a fair amount of heat. And what's inside of here is a giant glass tube that's kind of like shaped like a bell on its side. At this end, at the far end, is an electron gun, a little device that shoots electrons out. And then it passes through a series of magnets, electromagnets, right about here. And then from there, the electrons will get deflected either to the left or to the right or up or down, depending upon the orientation of those electromagnets. So there's one set of magnets that deflects the electrons up and down. There's another set of electromagnets that deflect the electrons left and right. And those work in concert together to basically paint the pixels on the screen from left to right and then from top to bottom. And so these days, your LCD monitors are still arranged the same way. You've still got the 0, 0 pixel up here in the top left, because that was the first pixel that was painted by the CRT gun. It started here in the top left, and it went left to right, and then went to the next line. And it did that, 60 times a second or thereabouts. So each complete screen was painted from top to bottom in 1/60th of a second, and then it would start over again. It would snap back from this lower right-hand corner up to the top left, and then start the process over again. Okay, so the screen itself is being painted 60 times a second, and the pixels are being painted at a much higher frequency, right? Each pixel is coming out. There's about, I don't know what the dimensions this way. It's 500, 280, 560 pixels this way, and I think it's about 200 pixels this way. So it's not square. And so that makes about 1,000 or so pixels altogether. No, not 1,000. What is it, 500 by 200? 10,000, about 10,000 pixels altogether. And then you're doing that 60 times a second. So the pixels are being painted on the screen pretty quickly. And what that means is that this CRT emits a very high frequency pitched whine. Now, I'm in my 50s. I'm 51 years old. I can't hear that anymore. When I was younger, I could hear that whine pretty loudly. That whine drives my kids bonkers. They can hear it. They can hear that high-pitched, about 15,000 hertz sound coming out of the CRT. My dog can hear it too. He's not here. So that's one of the nice things about LCD monitors, is that they don't emit that high-pitched sound. And they don't get hot like these things do. And so my kids always know when I got this computer turned on, because they're like, "What's that sound?" It's driving me crazy.
They don't take up 3 cubic feet of desk space.
The monitors anymore, the LCD monitors.
Yeah.
But my cats loved it. When I had my computer on, they would go, "Ah, there's a nice toasty place for me to sit down." And so they would get on top of that CRT and just sit there all day. And then I think it was back in like the late 1990s, I finally got my first LCD monitor. It was a 17-inch LCD monitor, and I promised myself that when I saw those monitors drop below $1,000 at Costco, I was going to buy one. And sure enough, $999. I said, I'm getting one. 17-inch LCD monitor. My cat was in for quite a surprise that day. Looked up and went, "Oh, the monitor's on. I shall hop on top of that thing." Did this little balancing act for about 5 seconds before it said, "I'm out of here." But I basically haven't gone back since. Let's see. McNano says, "I missed the CRT sound. I could tell when the TV was left on." Sure enough, right? You could tell when the family TV was on by that high-pitched sound. Pascal syntax looks like Lua. It does, kind of. I mean, a lot of languages really got their roots in Pascal. Pascal was in the 80s, and then all these languages branched out from there. Took basically the Pascal look and feel and just changed the syntax a little bit, changed the types of variables, how you do loops. But basically, a lot of them got many of their syntactic rules from Pascal. Pascal died so that others could live. And you know, CRTs are also sometimes nice because they're not as sharp as LCDs. Sometimes you take some of these old retro game consoles, like the old Nintendos or the old Ataris, and you plug them into a modern LCD display, and the graphics are too crisp. The game designers back then actually took advantage of the fact that your CRT blurred the pixels just ever so slightly so they could blend some of the colors together and make textures that kind of all came together because they were a little bit fuzzy. You put them on an LCD and it's too sharp. You can see every single little detail that you weren't able to see back in the CRT days. So some people like to go to thrift stores and find old CRT televisions in order to run their old retro consoles, because then you see the graphics the way the graphic designers intended to see them. Plus, also, some of the new LCD TVs can't pick up the signal from a retro console. The retro console is outputting the video display on that yellow jack, but it may not have been a signal that was strong enough or was followed the standards well enough for a modern TV to pick up on. So you might plug those things in, plug in an old Nintendo, and then like nothing appears on the TV because the signal's not strong enough or something like that. So you actually have to go back and find an old style television to be able to play those old retro games. Dimitri says, as I remember in Pascal, it's possible to use pointers. Yes, Pascal did have pointers, although they were kind of hidden from you. If I remember my history, Pascal history, the designer of Pascal, Nikolaus Wirth, initially did not want pointers at all. Wanted to be able to do all the programming you needed without explicit use of pointers, and then had to add them on later because you can't, without pointers, you can't do things like linked lists and trees. So had to add on some syntax to allow you to use references to other things. So you can make a record to represent a node in a tree, and then, so you can have a value and then pointers to two other records. Wolfgang says, in Turbo Pascal on the IBM PC, you could use inline assembler in Pascal code. That is correct. Well, actually, you can still do that in, not in Java, but in C. You can use the ASM keyword, and then everywhere, you say ASM and then curly brace, and then everything between the beginning curly brace and the end curly brace can be assembly code for the particular processor that you're running on. You can still do that in the C language. John says, I have an old CRT for my Nintendo 64 and GameCube. Just for that purpose, right? Yeah. It's great keeping those things around. You might have noticed, though, that if the TV is fairly old, the picture has gotten a little blurry over the years. But it's okay, right? It works okay. Ziggy says, what is the text editor? So that's just the text editor that came with Apple Pascal back in the days. It's not it doesn't have a name, right? It's not VI, it's not Nano. It's just the one that came with that development environment. Oh, John says, that's why you actually like it. It's a little bit blurry. I mean, like, it's a little blurrier now than it probably was when it was new. The stuff's just wearing out inside. It's possible to fix it. It's dangerous to fix it because when those things are on, there's about 15,000 volts running through them, and so you can touch the wrong thing and then find yourself on the opposite side of your room with a bad concussion. But when you're working on these old vintage computers, like the one I've got, whoops, back over here, that's what you have to do. You have to learn how to open them up and be safe inside those things. Any other questions? No? Are we good?
Professor?
Yeah.
I have a question about assignments. I got carried away by my other classes. This semester has been so difficult. Is it still possible to turn in some late assignments to
Yeah,
you?
yeah, you can turn in assignments up until we meet sometime next week. So
Okay, awesome. Thank you.
yeah,
I'll spend the day tonight and tomorrow doing that stuff.
yeah, try to get them in by the weekend at the very latest, so that I
Thank
have
you so
time
much.
to
Appreciate
go
it.
through and add up all the scores. The other Dimitri says, I remember how it was possible to include something like GDI and draw primitives in Pascal. Yeah, this Apple Pascal can actually do graphics. I don't remember how to do it, but it can do graphics. So it can, and also the basic. I didn't show that to you. The basic in Apple could do graphics as well. They were really primitive. Basically, you could draw dots and you could draw lines. That was about it. Anything else you had to write yourself.
Professor, what is Pascal being used for nowadays? Because sometimes if I go like on Monster or Indeed, I see those languages in requirements for the.
I could only suspect that one of two things is happening. One is the hiring manager doesn't know what he or she is talking about and just threw it in there because it looked good. The other might be maybe this company is still using Pascal because they've got programs left over from the 1980s and 1990s they're still maintaining.
Okay.
Otherwise, it's pretty much a dead language. No one uses it for modern stuff. So my guess would be it's probably the latter. They probably have programs, really old programs that they need maintenance on. But it could also be hiring managers threw it in there. They don't really use it. Legacy code, it's called. That's right, Ziggy. Legacy code. Old stuff. Okay. Well, I think that's about it for today. I hope you got something out of that. If you go on YouTube, there's lots of channels where people are showing off their old vintage stuff. There's like the 8-bit guy who shows off Commodores and Apples and Ataris and also shows you how to fix them if you run across ones in like a thrift store or a garage sale, and you want to fix it up and get it working again. I've got some other old vintage stuff. You can't see it on my background because it's cut off by the top, but I got a Commodore 64 up there. I've also got an old Radio Shack Model 102. It's one of the very earliest laptops. Right here. This laptop ran off of AA batteries, 4 of them, and one set of batteries would last about 2 or 3 weeks. It's got I don't have any batteries in it right now, but it's got a black and white LCD display. I think it had 40 characters across and 8 lines down. And you could also put it into a graphics mode, so you can do some basic graphics on here. Full size, full travel keyboard. It's not like the little flat keyboards that laptops have now. And it had some ports on the back. So you've got one for your modem, you got one for your printer, your cassette tape for saving and loading programs, and a phone, I guess, for something. Plus a port on the back for direct access to the processor itself. And then a reset button. And then on the bottom you got your battery case, you put your 4 AA batteries in there. And then here's where you could pop this open and there's a place for you to install, I guess what you would call expansion ROMs. So you could put, like, if you had a program on there that you wanted to load in permanently, you could get it on a little chip and just pop it right in there. So 2 to 3 weeks on one set of batteries. Not too bad. Oh, also came with BASIC, so you could get started right away programming it. Came with BASIC, a really simple word processor, a really simple spreadsheet, a really simple database, and then a program for working with a modem. So it came with 4 programs plus BASIC. And that's what you got for your money. There are still people that carry these around. They got great keyboards on it. This is like, a regular keyboard like you would find on an old vintage computer. So it's not like the flat keyboards, it's a full travel keyboard. And there are some people whose job it is to write, like journalists, authors, who carry these things around because they're great writing machines. If all you want to do is just do writing, although we're typing, all you want to do is just do typing, this is a great machine. And of course, it'll last for 2 or 3 weeks on one battery charge. And you can get the batteries anywhere. So you run out of batteries, you don't have to go and find a charger. You just go to the local convenience store, pick up 4 more batteries, and away you go. What was the available memory on that laptop? I think it came by default with 24 kilobytes, which seems silly these days, right? But it was enough to hold those 4 programs. 24 kilobytes, I think you could expand it up to 32. So it had space for you to pop 1 more RAM chip in there, which I did on this. So it's got a whopping 32 kilobytes of memory. And there are enthusiasts out there producing expansion boards for it. They're producing one that, of course, they've got a board you can put in there that has like a megabyte of memory on it, a megabyte of flash memory. So it's basically a little flash drive with a megabyte on there, and you can store all sorts of programs on there. You can store operating systems and programs. You can run CP/M instead of its non-operating system. You can run like a stripped-down version of DOS. You can run BASIC. You run people running C compilers, Pascal compilers. So the hobbyists are like doing great stuff with this old computing equipment and making it, breathing new life into it, which is really great to see. That people are able to take this old equipment and add new functionality onto it and make it also work with modern equipment. You put those things on the internet with the right expansion board. Yeah, 24 kilobytes. That's all you got. But you know, on an 8-bit processor, the most amount of memory you could access was 64 kilobytes. Because an 8-bit processor had 8 bits for its data, and usually it had a 16-bit address bus. So with 16-bit addresses, you can access 64 kilobytes of memory. And that was where it maxed out. That's all you could do. When 32-bit processors later came into the marketplace, the most amount of memory you could access was 4 gigabytes. That's it. You topped out there. So if you had more memory than that, it meant your processor was doing some fancy stuff behind the scenes in order to switch out banks of memory so that you could access more than 4. But 4 was it. That's as most you can access with 32 bits of addresses. And of course, memory back then was really expensive. You wanted to boost that thing from 24 to 32 kilobytes, you know, you're probably going to spend about $100 to do that. $100. So a lot of money. I know there's that famous quote, 640 kilobytes ought to be enough for anybody, said Bill Gates back in the day. There was also an executive at IBM that said he thought that the most number of computers that the entire world would need was 7. He didn't see a market for computers. He thought the most the world would ever need is 7 computers. And that's it, right? You've saturated the entire market. So why would IBM go into the business of producing computers if the most they would ever make is 7? So for a long time, IBM just did typewriters. Interestingly enough, they were the ones that eventually kind of started the whole PC revolution, right, with the IBM PC. Once they realized there was a market for more than 7 computers, then they got into it. Okay, so for those of you who are in my class, I'll just repeat this again. Hopefully within the next day or two, you'll see the schedule for Zoom sessions that you can sign up for. Plus, you'll see a survey that you'll fill out that has reflections about the class. What did you learn? What did you have challenges with? What was like your favorite assignment? Stuff like that, so that when we do meet for our 5-minute meeting, we can just very quickly go through the answers to those questions. Okay? So I will see you actually briefly on Monday. We'll do our stream from about 9:30 to 10:30, and then I got to get into those Zoom meetings.
All right. Thanks,
All right.
Professor.
Yep. Well, I hope you had an enjoying day today. Enjoy. What am I trying to say? Enjoy. Hope you enjoyed today.
Thank you, Professor.
Yeah. Take care,
Thank you.
everyone.
Have a good day.
Good luck studying for your finals. I'll see you later.
Take care.
Bye. And then I have to stop the YouTube stream separately. Yeah, ThinkPads were great laptops. They were durable. If you didn't like to use a mouse or a trackpad, it had that little nub in the middle of the keyboard that you could use for the mouse. A lot of people really liked that. It was a little, almost, they called it like a pencil eraser because it almost looked like the very tip of a pencil sitting in between the G and the H keys, I believe. It was this little thing. You put your finger on it and you could just barely move it to the left or to the right or up or down, and that would move your cursor around on the screen. But a lot of people just loved that because they weren't used to using trackpads. Or, more likely, back then, trackpads were just awful. They didn't detect your finger very well. They skipped, they jumped. This was a lot more reliable. Once trackpads got good enough, I think, then they kind of dispensed with that. Although I think you still can get ThinkPads from IBM that still have that in the keyboard. Of course, now these days, the IBM laptops are called Lenovo's, and I'm looking at pictures of them, and yep, they still have that. They still have that little thing on the keyboard. Yep, sitting right between the G and the H keys. There it is. And they don't have a trackpad at all. They just have the 3 buttons down here, and then that thing. I could never get used to it. I didn't care for that thing. Oh, newer models ThinkPads don't have the original keyboard, so the keyboards kind of are awful, but at least they have the little eraser. Yeah, in the name of making things cheaper to produce, easier to fix, the keyboards have sometimes gotten lower quality. Instead of individual key switches, some keyboards just use a rubber membrane with little bumps on it, and the keys just press down on that rubber membrane, kind of like a little bubble, and then when it presses down, it makes contact below. Those are really cheap to manufacture. And even the key switches themselves, you've got the little butterfly, or not butterfly, scissor switches. You can still kind of cheapen those out as well. You can use different kinds of plastics that are more flexible rather than stiff. If they're nice and stiff, then you get a nice good scissor action. If they're kind of flexible, then it get kind of a sloppy action. Or you can make the scissor mechanisms shorter, and again, you don't get as much travel on them. Or underneath the keyboard, you should ideally have a really stiff material to keep the keyboard from flexing. And so a lot of laptops put like a piece of aluminum back there, a stiff piece of aluminum to keep the keyboard from flexing. If you want to cheapen that out, you can just put a piece of plastic back there, and then the keyboard flexes a little bit. Again, giving it kind of a mushy, cheaper feel to it. All right. I think that's the end of the stream for today. So tomorrow being Thursday, I'll have my C programming class. And in there, I think we're going to be doing a quantum computer simulator, a very low-end one, stripped-down one, but at least you get the idea about how quantum qubits are represented in a computer and a simulator, and how you can do some computations with it. So I think that's it. I hope you all have a good day or good evening, depending where you are. It's good to see you all. And I will see you either tomorrow or next week. So have a good one, everyone. Take care. Take care of yourselves. And I'll see you later. Bye-bye.